Hi everybody, welcome to our video. My name is Ross Turner.
I'm Michelle Valdez.
I'm Kyle, and we're here to talk to you about what radiation is.
Radiation in space.
And what radiation does to the human body, and especially to astronauts in space.
What is radiation? Radiation is energy that is emitted as either a particle or waves. In this picture, there are 4 different types of radiation. The first one is acoustic radiation, which is like change in pressure. The second one is electromagnetic radiation. They are gamma rays, or in this picture, an X-ray. The third one is particle radiation, which are alpha, beta, or neutron radiation. And the last one is gravitational waves. This could be solar, terrestrial, or galactic cosmic radiation. There are 2 types of radiation that I'll be focusing on today. Those would be electromagnetic and particle radiation. Electromagnetic radiation can be split up into 2 categories: non-ionizing radiation and ionizing radiation. There's a big difference in what that does to the human body. Non-ionizing radiation has enough energy to move around our atoms in a molecule, but not enough energy to remove an electron from the atom. For an ionizing radiation, this has enough energy to move and knock electrons out of the atom. This is when things get dangerous and can affect the human body. There are 4 main radiation types that we'll be looking at when we talk about electromagnetic radiation and particle radiation. Those would be alpha, beta, gamma, and neutron radiation. These are all very harmful to humans. The first particle we'll be looking at is an alpha particle. This interacts strongly with matter. This particle can be stopped by a sheet of paper or a protective layer like our skin. It can only travel a few inches. The next one we'll be looking at is the beta particle. This radiation is external and internal hazard to humans. This can travel in 10 to 20 feet in the air, but it can be stopped by aluminum or plexiglass. The third one we'll be looking at is gamma. Gamma radiation is electromagnetic radiation. This is a whole body hazard to humans. This can travel many feet in air, but it can be stopped by lead or steel. The last one we'll be looking at today is neutron radiation. This is particle radiation that can be a hazard to the whole body. This can travel up to 1,000 meters. It can, however, be stopped by hydrocarbons like water. We have made a demonstration that helps show how each of these radiations can be stopped. For this demonstration, you will need a piece of paper or a tissue or a paper towel, a sheet of aluminum foil, a ping pong ball, a bouncy ball or a wiffle ball, and a tennis ball or a golf ball. This first demonstration will use the ping pong ball and either the piece of paper, the tissue paper, or the paper towel. Have 2 people hold the paper of choice and have someone try to throw the ping pong ball at the piece of paper. You will see by this acts as an alpha particle, that it can't get past the piece of paper. Next, you're going to use a bouncy ball or a wiffle ball, and that's going to be in place of what a beta particle would be. So you're going to have 2 people hold the piece of aluminum foil, and you're going to toss the bouncy ball or the wiffle ball at the aluminum foil, and you'll notice that it can't get through the piece of aluminum foil. This acts as a protective barrier against the beta particle. Lastly, you're going to use either a tennis ball or a golf ball, and this is going to act as a gamma particle. For this one, what you'll do is you will toss it at the concrete wall in your classroom, and this is acting as a thick piece of steel or lead that can stop a gamma particle.
What is space radiation? Space radiation is made up of atoms whose electrons, one of the 3 main parts of an atom, have been stripped away as it moves fast along space. When this happens, only the radiation causing center or nucleus of the atom remains, and this is what we know as space radiation. The 3 types of space radiation are solar, terrestrial, and galactic cosmic. Solar radiation is caused when particles are expelled from the sun by its nuclear fusion reaction. This reaction is what gives the sun the heat and brightness you feel and see. Solar storms and flares can cause big eruptions with that sun's high energy radiation and expel this radiation into space and even onto Earth. The next type of radiation is any radiation emitted from Earth. This is called terrestrial. This radiation comes from when natural resources on Earth, such as rocks, soil, or plants, break down. The next time you see the summer leaves start to turn orange in the fall and land on the ground, think about the terrestrial radiation it's causing. The last type of space radiation is galactic cosmic. This is background radiation that's found in our solar system. This radiation is left over from supernovas, which are powerful explosions when a star is at the end of its lifespan, or even from the solar storms and flares that we learned about earlier. But how does the Earth protect us from this space radiation? Luckily, the Earth's magnetic shield protects us from space radiation by acting exactly as its name implies, a shield that deflects most radiation that may hit, but unfortunately it doesn't block all. Some of the remaining radiation from space that does pass through that shield is blocked by the ozone layer that absorbs any hazardous radiation in the upper part of Earth's atmosphere. But even though we have these two protective shields, some radiation still passes through Earth from space, like UV or ultraviolet light that comes from the sun and gives us sunburn.
Now that we've talked about what radiation is and the types of radiation in space, we're going to talk about our third big concept, that radiation can damage the human body, especially over time. Every time you step out into the sun, or use a microwave, or get an x-ray, you're exposed to radiation. So, what does this radiation do to our bodies? Well, it all depends on the dose and type of radiation that the body is exposed to. Dose means the amount of radiation that the body receives. Our natural environment exposes us to low levels of radiation, but things like x-rays at the dentist, or spending time in the hot sun, or for astronauts spending time outside the Earth's protection, increases the dose we receive. The type of radiation also matters. Alpha radiation is easily blocked by our skin, but beta, gamma, and neutron radiation can enter our bodies and cause damage. This damage is all because radiation can break the bonds in our DNA. DNA is the instructions for how our body works, and if it's damaged, the body can stop knowing how to work correctly. Radiation can also create free radicals. These are dangerous molecules that move around our body and cause problems. So, what happens when our DNA is damaged and free radicals move around the body? This can cause cancer or even cause organs like the heart, brain, or kidneys to stop working properly. We've learned a lot about radiation from cancer research and even cancer treatment. The good news is that our bodies are good at healing themselves and often can repair damage caused by radiation. Over time, however, the damage can build up and cause serious health problems. To protect against radiation, you can do simple things like wear sunscreen, eat vegetables which have nutrients that help the body protect against radiation, and use proper procedures and safety when using machinery that uses radiation. In space, astronauts get some protection from their spaceships and their space suits, but scientists want to find more and better and safer ways for humans to go to space.
Alright, that's the end of our video. I hope you learned a little bit about how to protect yourselves from radiation and what radiation is.
The three types of space radiation.
And that too much radiation can damage our bodies. Hopefully you've learned a lot and are excited to learn more about radiation. As you learn more, maybe you'll be the one to discover the way to protect astronauts in space as they travel among the stars. Now that would be out of this world. Thanks for watching.